universe is vast, colossal, ancient, full of secrets yet to be unraveled. Amidst the thousands of stars that shimmer in the black velvet of the cosmos, some are similar to our own sun. Around them, planets orbit, silent, unseen, waiting to be discovered. In recent decades, humanity has taken bold steps into this invisible frontier, unveiling an astonishing diversity of alien worlds. Some of them are gas giants spinning beside scorched stars. Others are rocky infernos or frozen deserts, orbiting their suns too closely or too distantly to support anything we might call familiar. And then, among all these exotic spheres, a name quietly emerged: Kepler-22, a world located in what scientists call the habitable zone, the not too hot, not too cold region around a star where conditions might be just right for liquid water to exist. It was one of the first such planets ever found beyond our solar system, a planet that sparked global curiosity and whispered a simple question: could this be a new Earth? The story of Kepler-22b begins with the Kepler Space Telescope, a revolutionary observatory launched by NASA in 2009. Unlike traditional telescopes that capture sweeping images of the night sky, Kepler had a singular mission: to stare, unblinking, at a single patch of stars and look for dimming patterns that might suggest the presence of orbiting planets. And on December 5th, 2011, the announcement came. A new exoplanet had been confirmed, orbiting a sun-like star in the constellation Cygnus, roughly 620 light-years away from Earth. It was dubbed Kepler-22b, the 22nd star system cataloged by the telescope, and the first to reveal a planet in its habitable zone. This moment was historic. For the first time, humanity had found a planet beyond the solar system that was not only roughly Earth-like in temperature, but also revolving around a star not unlike our own. Though we still knew little, Kepler-22b became a symbol of potential, the first in a new era of discovery. Kepler-22b orbits a G5-type star, slightly smaller and cooler than our Sun. This star, known simply as Kepler-22, lies in the direction of the Swan, Cygnus, a familiar constellation in the northern hemisphere. While it's about 10% smaller than the Sun and emits a bit less light, its overall characteristics are comfortingly familiar. The planet itself completes one full orbit every 289 Earth days, a year slightly shorter than ours. This places it comfortably within its star's habitable zone, at a distance that allows temperatures to potentially support the presence of liquid water. But while the host star gives us hope, the real mystery and fascination lies in the planet itself. Let's be clear, Kepler-22b is not an Earth twin, it's a distant cousin at best, and perhaps something stranger still. Based on the depth of its transit, the amount of light it blocks when passing in front of its star, scientists estimate that Kepler-22b has a radius about 2.4 times that of Earth. That's a considerable size jump. In terms of volume, it's roughly 13 times bigger than our planet, yet its mass remains unknown. We have no direct measurement of its weight, which means we can't say for certain what it's made of. Is it a giant rocky planet, like a scaled-up Earth? Or is it a miniature Neptune, shrouded in thick gas layers with a dense, possibly icy core? Both are viable models. This ambiguity is key. If Kepler-22b is predominantly rocky and has a thin atmosphere, it could be one of the most promising locations for life beyond Earth. But if it's a gas-dominated world with crushing atmospheric pressures and no solid surface, its Earth-like orbit might be misleading. This is the duality that defines Kepler-22b: familiar, yet unknowable; a mirror, yet a mystery. Based on its distance from its star and the type of radiation it receives, Kepler-22b's surface temperature could be around 22 degrees Celsius, a pleasant 72 degrees Fahrenheit, if it has an atmosphere similar to Earth's. But that's a colossal if. A dense, carbon-rich atmosphere could trap heat, creating a runaway greenhouse effect like Venus. A thin atmosphere might not insulate the planet at all, rendering it frigid. And of course, a deep gaseous envelope might mean there is no true surface to speak of, just deeper and denser layers of hydrogen and helium. Interestingly, some models suggest that Kepler-22b could be an ocean world, a planet covered entirely by deep global seas, hundreds of kilometers deep, deeper than any trench on Earth. If so, then beneath those waters might lie hydrothermal vents, warmth, and the right chemistry for life to take root. Much like life may have originated in Earth's ancient oceans. Could there be waves crashing on unseen shores, or only endless aquatic twilight stretching over a hidden abyss? When we speak of habitability, we tend to imagine Earth-like conditions, a rocky surface, a temperate climate, breathable air. But habitability may be a broader concept than we ever imagined. Kepler-22b could support microbial life, or even complex aquatic ecosystems, if its conditions are right. But there's also a darker possibility that it's lifeless, that its oceans, if they exist, are sterile, or that it's enveloped in toxic gases, or has a core of rock covered by crushing kilometers of ice and fluid where light can never reach. These possibilities show us the limits of current technology. We can detect planets, estimate their size and orbit, and dream of their landscapes, but we cannot yet see them directly. Every image of Kepler-22b you've seen is an artist's impression, informed by physics and creativity alike. We stand on the edge of understanding, peering into the dark. One of the great challenges with Kepler-22b is the lack of direct atmospheric data. Unlike closer exoplanets whose atmospheres can be studied through spectral analysis during transits, Kepler-22b is simply too far and too dim for current instruments to analyze in detail. But speculation is not without value. Based on its size, researchers have proposed several models for its interior and structure. Some suggest a thick envelope of water and ice over a silicate metal core. Others propose a more Earth-like layout with a mantle, crust, and surface oceans. There's even the tantalizing idea that Kepler-22b might possess a moon, a massive, possibly habitable exomoon orbiting the larger planet, shielded from harsh radiation, warmed by tidal forces. Such a scenario, while still speculative, opens the door to an entire system of interest. Not just a planet, but perhaps a family of worlds. At present, no spacecraft is en route to Kepler-22b. At 620 light-years away, even our fastest probes would take tens of millions of years to arrive. But that doesn't mean we're blind. New telescopes like the James Webb Space Telescope and the upcoming Nancy Grace Roman Space Telescope may one day allow us to characterize exoplanet atmospheres at greater distances. If a future generation of instruments detects chemical signatures like oxygen, methane, or water vapor on Kepler-22b, it would be a milestone for science and a quiet revolution in how we see the cosmos. Some even imagine a more distant future when interstellar probes, perhaps propelled by solar sails or fusion engines, could travel to systems like Kepler-22. It would take centuries or millennia, but the dream endures. The discovery of Kepler-22b was not an isolated event. It was the first confirmed habitable zone exoplanet, but it ushered in an avalanche. Since then, thousands more have been found. Super-Earths, mini-Neptunes, and rocky exoplanets in their stars' habitable zones now fill our databases. Some, like Kepler-452b, are even more Earth-like in certain ways. Others, like TRAPPIST-1d and TOI-700d, orbit dim red dwarfs, where the rules of habitability may be entirely different. Yet Kepler-22b remains iconic, a first glimpse, a symbol of what's possible. It taught us that planets like Earth may not be rare, that life perhaps is not an anomaly, but part of the fabric of the cosmos. Imagine for a moment standing on the surface of Kepler-22b, if such a surface exists. The sky might be blue or green or purple, depending on its atmosphere. Its sun, Kepler-22, would shine less brightly than ours, casting a gentler light. Perhaps you'd be standing on a rocky coast, watching alien waves roll in from an endless sea. Or maybe you'd be floating in a deep ocean, with nothing beneath but the quiet pull of gravity and the whisper of unknown currents. Above, the sky might shimmer with clouds made of vaporized elements foreign to Earth. And all around, silence, time, infinity. Kepler-22b may not be Earth 2.0, but it reminds us that the universe is a gallery of worlds. Some will be familiar, others will defy understanding, but all of them, every last one, tells us something about our place in the grand design. As we sit here on Earth, spinning in our own orbit around the sun, we look up at the night sky and wonder. Kepler-22b remains far beyond our reach, its light having traveled for 6 centuries before touching our telescopes. And yet, in a strange way, it is close, not in distance but in meaning. It reflects our hope, our hunger to explore, and our deep yearning to not be alone. Whether it harbors oceans or deserts, clouds or storms, life or silence, it matters. Because the discovery of Kepler-22b didn't just change astronomy, it changed how we see ourselves. Who knows what awaits among the stars? The answer, perhaps, lies on a blue world far away, waiting patiently for us to find our way home. But Kepler-22b was just the beginning. 3 years later, our gaze shifted once more, this time even farther into the galaxy. Another signal, another world. Among the countless stars shimmering in the darkness of space, many host their own planetary systems. Some worlds are scorched by the relentless heat of their stars, while others are locked in perpetual twilight and ice. Yet hidden within this cosmic grandeur may lie planets whose conditions bear a striking resemblance to our own Earth. On these planets, vast oceans could stretch as far as the eye can see, clouds might glide across the sky, and flashes of lightning could illuminate distant horizons during thunderstorms. It's tempting to believe that life has found a way to flourish there, just as it once blossomed here on Earth, in its oceans, forests, deserts, and at the icy poles. And yet, life itself remains one of the most astonishing, complex, and mysterious phenomena in the universe. Despite thousands of years of study, we still lack answers to many questions. The biggest being, does biological life exist anywhere beyond Earth? And if it does, where should we look for it? And how would we recognize it? In pursuit of answers, humanity has undertaken extensive investigations of planets circling distant stars, exoplanets that could potentially resemble our own world. Astronomers have already confirmed the existence of thousands of these enigmatic objects. Some orbit old, faint stars, while others circle young giants that emit overwhelming energy. Yet in evaluating each new world, scientists specifically look for signs of water, an essential suite of chemical elements, and moderate temperatures, the very conditions that make life possible as we know it on Earth. To gauge how Earth-like a particular exoplanet might be, researchers have developed a special measure known as the Earth Similarity Index, ESI. Let's explore what it is, how it's used, and how it relates to one of the most intriguing exoplanetary discoveries to date, Kepler-452b. The Earth Similarity Index, ESI, is among the simplest and most common tools for a quick assessment of how closely an exoplanet's basic characteristics match those of Earth. At its core, the ESI involves 2 key parameters, the first being surface gravity. It's calculated from a planet's mass and radius. If the gravity is significantly higher or lower than Earth's, organisms similar to those on our planet might face serious challenges in terms of body structure and metabolism. The second factor is temperature, which is derived approximately from the planet's distance to its star and the star's brightness, or luminosity. If the temperature is too low, water remains locked in ice. If it's too high, water can only exist in vapor form. Both extremes are unfavorable for Earth-like life. Combining these parameters yields a single score that reflects the degree of similarity to Earth. However, this metric has clear limitations. It does not account for other key characteristics, such as stellar activity and orbital nuances. Red dwarfs often unleash powerful flares that can strip away atmospheres and intensify radiation exposure, while massive stars, like Sirius or Vega, live too briefly for complex life to develop. Orange and yellow dwarfs, such as our Sun, are generally considered more promising hosts. If a planet orbits too close to its star, it can become tidally locked, leaving one side perpetually scorched while the other remains in darkness and cold. Conversely, if it lies too far away, it risks freezing beyond the habitable zone. Despite these drawbacks, the ESI is a convenient, quick filter because calculating it requires only basic information about a planet's mass, radius, and orbit. Earth naturally serves as the gold standard by which we judge conditions capable of supporting life. Kepler-452b was discovered by NASA's Kepler Space Telescope, launched in 2009 to detect planets around other stars via the transit method. The principle is simple. When a planet crosses the face of its star, it blocks a small portion of the star's light, causing a slight dip in brightness. By measuring these dips, astronomers can estimate the planet's orbit and approximate size. In 2015, NASA scientists announced the discovery of a planet designated Kepler-452b. Why did it spark such excitement? The star Kepler-452 is very similar to our Sun in spectral class, and Kepler-452b orbits within the habitable zone, far enough from the star that, if it has a suitable atmosphere, liquid water could exist on its surface. Additionally, its radius turned out to be only about 1.5 times larger than Earth's. All of this led researchers to speak of potentially Earth-like conditions. Kepler-452, the planet's host star, is located about 1,400 light-years away in the constellation Cygnus. Its spectral type is G2, practically the same as our Sun. However, astronomers estimate that Kepler-452 is about 1.5 billion years older. This makes the system particularly interesting. If the exoplanet has remained in a habitable zone for so long, life there could have had more time to arise and evolve, assuming other conditions were favorable. Kepler-452's mass and luminosity are only slightly higher than the Sun's, and its surface temperature is comparable to solar values. In terms of chemical makeup and evolutionary path, Kepler-452 follows a similar pattern, but is at a more advanced age. Scientists often refer to such stars as solar twins, pointing to their significance in the quest for life-bearing worlds. It's believed that Kepler-452b completes one orbit in around 385 Earth days, meaning a year there lasts about a month longer than ours. Calculations show its orbital radius is just a bit larger than Earth's, placing it slightly farther from its Sun-like star than we are from ours. Thanks to Kepler-452's slightly greater brightness, the planet may still receive roughly Earth-like levels of energy, maintaining a similar energy balance. Of course, there are many unknowns. We lack precise data on heat distribution, axial tilt, and possible moons. Even so, the mere fact that this planet's year is close to 385 days, coupled with its location in the habitable zone, sparks the imagination. We can't help but picture what it would be like if we were there, how much longer the seasons might last, and how different their cycle might be. Kepler-452b's radius is about 1.6 times larger than Earth's. On one hand, this leaves open the possibility of a solid surface rather than a purely gaseous envelope. On the other, such a larger radius may indicate that the planet is closer to a mini-Neptune or a super-Earth with a thick atmosphere and strong gravity. Determining its mass is difficult, but models suggest it could be 5 or 6 times Earth's mass if it's mostly iron and rock. Its internal structure remains a mystery. It could possess a hot iron core surrounded by a silicate mantle and crust, or perhaps it contains extensive layers of ice and water if it formed farther from its star. Its substantial size increases the likelihood of a dense atmosphere, yet we don't know if this atmosphere is breathable, toxic, scorching like Venus's, or something entirely different. As soon as scientists announced the discovery of Kepler-452b, media outlets splashed headlines about Earth's twin and New Earth 2.0. However, experts advise caution. While the orbit and star of Kepler-452b appear promising, countless factors ultimately decide whether a planet can be hospitable to life. A key question is the atmosphere. If a runaway greenhouse effect has developed, the planet may be superheated like Venus. Conversely, if the atmosphere is too thin, stellar radiation could overwhelm its surface, or the water could simply evaporate into space. A planet's magnetic field, crust composition, and tectonic processes are also critical, but currently unknown. Even so, the fact that it lies in a habitable zone around a sun-like star gives hope for favorable conditions. Since the Kepler mission, other space observatories and ground-based telescopes have added Kepler-452b to their watch list. Instruments like the Hubble or ground-based Very Large Telescope, VLT systems, can at least refine what we know about its star and look for subtle gravitational effects. However, a full spectroscopic study of the exoplanet's atmosphere is still extremely difficult. Kepler-452b is simply too distant, and its star not bright enough for current technology to analyze in detail. Still, the future holds promise. Next-generation telescopes, such as the James Webb Space Telescope, and planned giant Earth-based observatories boasting mirrors over 30 meters in diameter with advanced coronagraphs may eventually reach the precision needed to probe certain atmospheric traits of Kepler-452b. Detecting water, oxygen, or methane in its spectral data would be an exciting hint of biological activity. This work is daunting, but technological breakthroughs over the past decade inspire optimism. If Kepler-452b has indeed sustained a stable climate for hundreds of millions or even billions of years, evolutionary processes akin to those on Earth might have had more time to unfold. Since its star is older than the Sun, this world could have had a longer window to develop, or conversely, to run out of resources. Hypotheses abound, but none can replace the certainty that direct observations might bring. Then again, life on this planet, if it exists, might be drastically different from our own biosphere. There is no guarantee of photosynthesizing plants or carbon-based chemistry. Life could have found an entirely different path. Nonetheless, such possibilities fuel advancements in astrobiology, inspiring improvements in our search techniques for habitable worlds, and guiding us to learn how common Earth-like conditions might be throughout the cosmos. The idea of sending an expedition to Kepler-452b is mesmerizing, but at 1,400 light-years away, it lies beyond the reach of any technology we currently possess or might have in the near future. Even traveling close to the speed of light, the journey would take well over 1,000 years. Science fiction, however, loves to explore concepts of generation ships or revolutionary travel methods, keeping the dream alive. For humanity, the very existence of such a nearly Earth-like planet at that distance highlights the vastness of the universe. If these worlds are real, then perhaps somewhere among them are beings who have passed their own prehistoric era, discovered science, and built telescopes to look for fellow, intelligent life. This thought inspires us to push research further, never losing hope that we'll someday gather more direct evidence of life around the corner. Essentially, Kepler-452b is but one among thousands of exoplanets, yet it vividly illustrates a compelling idea. There are worlds out there that might be very much like ours. Each system, however, has its own story, and each planet its unique conditions. Observations of this distant super-Earth reveal how relatively small differences in radius and mass can profoundly alter a planet's fate. Perhaps it's home to temperate climates, or perhaps it's scorched by unbearable heat or beset by endless storms. Still, Kepler-452b's discovery bolsters our view that Earth is not a singular exception, but rather one of many celestial bodies capable of sustaining life. Direct data on its atmospheric composition, surface temperatures, or magnetic field remain a matter for the future. Yet even now, this planet expands our horizons, sets the stage for new missions, and drives scientists to search more intently for second Earths. One day we might find not just one, but dozens of potentially habitable planets, each with its own remarkable tale of how life can flourish among the stars. If you enjoyed this video, don't forget to give it a like and subscribe to the channel. It's the best way to show your appreciation for my work and inspire me to create more exciting content for you.